All right, so for due dates this week, we're going to complete Exploration 6.3 today in class. We might be talking a little bit about some of that stuff later on Friday as well, to see how far we get. 6.2 exploration points are due Thursday by 11 on Gradescope. I do want to remind you that if you're forgetting to turn these in, please email me and I can open things up, or you can send me screenshots of your explorations. You want to make sure everybody's getting those points. Exploration 7.2, we will be completing or working on in class on Friday. I do want to point out that it says RAT 21 and that there was no RAT 20. So I guess I just skipped the number for some reason. So RAT 20 and RAT 21 are basically the same RAT. So just make sure you complete that RAT by class on Friday. So by 10 a.m. actually on Friday. But don't think that you missed one. There just was no RAT 20. Sunday exploration points for 6.3, what we're finishing or working on in class today, will be due on Gradescope as well. And then just to put on your horizon that on the 28th, which is next Tuesday, your final project will be due. So I'll be giving you a little bit of information about that final project here in just a minute. And I also want to point out that our last quiz, it's not going to be due next Monday. It's actually going to be due Friday the 1st. It should come out either Thursday or Friday this week, so you can start working on that, but it won't be due until Friday the 1st, and that will be our last assignment for this class. All right, so I did finish grading everybody's results and appendix, so you should be able to read through and see the feedback given on that. This is just kind of to help you think about the order that you want your final paper in. So you should have your title and authors first. It is written as a final paper. This is not a draft at this point, so it should be complete. You want to include an abstract, which is like a 1 to 2 sentence summary of each section, the sections being the background, the methods, the results, and the conclusions. Just this is what we're going to look at. Any scientific paper that you read always has a background, so you can read through that, decide if you want to read through the entire paper. Background, methods, and results, you should read through the changes or read through the feedback given for those sections and make sure you make the appropriate changes. If you're not sure what I'm asking for or what I was responding on, make sure that you email me or come to an office hour to get some help on understanding those. The discussions and conclusions is the only new part of the paper that you won't have turned in yet. So make sure you read through what's to be included. I summarized it a little bit here. You should be writing conclusions for each research question, talking about how much evidence you have based on the p-value or the confidence interval for the alternative. So saying, based on our p-value of 0.002, we had very strong evidence that, and then a statement about your alternative hypothesis. We don't write conclusions about the null, so you don't need to talk about rejecting the null. We're just talking about this is what we can conclude based on the p-value or the confidence interval. You do need to include scope of inference, so think about how the sample was selected and then whether or not we can have causation in this study. You got to interpret each p-value and the confidence interval that was reported. If you already did that within your results, just move those into the discussion and the conclusions, because those should be in the discussions and conclusions. Then you're going to write a little bit about limitations and potential future research. What else could we do? What limitations were in this study? And then a couple concluding sentences that summarize their study. Then you should have your references or your citations from the background. So you guys already have those put together. They just shouldn't be in the middle of the paper. They should go at the end of the paper. And then you'll have your appendix. Any questions on the project? Okay, is everybody still there? You guys can hear me?
Yeah, we can hear you.
All right, good. Just want to double check. All right, so class today we are going to finish out Exploration 6.3. So we're looking at theory-based methods for testing a difference in means. So we're going to look at both the t-test and the confidence interval. And I learned a few things in my last class, so we're going to do a couple things differently than I taught in my last class, and it'll hopefully help us get through this information. So just a quick reminder of what we're looking at. We were looking at a study of the number of close friends, and we were comparing men and women. So this is just showing our simulation test. The averages here for the men and women. Remember, we don't care about this pooled data at all. So the average number of close friends for men was 1.86. The average number of close friends for women was 2.09. So we saw an observed difference of negative 0.228. In our simulation, we put that value in over here into our applet and found a fairly small p-value showing that we have very strong evidence based on a p-value of 0.016 that there is a difference in the number of close friends for men and women. Notice that we did have a hypothesized null of 0 because we're assuming there is no difference in the true mean number of close friends. Questions on that simulation? Okay. The simulation p-value, this is a different p-value than was on the previous page, but you probably got something close to about 0.0145. It is important that you're understanding where this interpretation came from, and understanding how to do an interpretation of the p-value. This is likely a question that will show up on the final exam. So this is kind of broke down by color, just showing you what we're trying to look at our measure here. So in 1.45% of simulated samples, that's the probability based on our p-value. The sample difference in mean number of friends for men and women of negative 0.228 friends. Order of subtraction, men minus women, that's our sample statistic. Or more extreme, that more extreme is because we're doing a two-sided test, will occur if the null is true, if there is no difference in the true mean number of close friends for men and women. Questions on that interpretation? And we know because this is a small p-value, then that's indicating that we will have strong evidence against the null. All right, so we're going to go ahead and go into breakout rooms for the first couple questions, looking at 9 through 11. So we've already finished through 8. 9 through 11 is just looking at what affects the p-value. So we're going to see if we make these changes, what would our p-value be? So are there any questions before I put you into breakout rooms? You able to see my slides again?
Yes.
Okay, so what's going to affect our p-value? If we have a larger difference in means, so our value is farther from 0, how would this impact the size of the p-value? Would it be smaller or larger?
Be smaller.
Right, we're going to end up with a smaller p-value, providing more evidence against the null, because our statistic, the difference in means, would be farther away from 0, it would be farther out in the tails of our null distribution. How about increasing sample size? What happens to our p-value?
It's smaller.
We also have a smaller p-value. We have less sample-to-sample variability with larger sample sizes. So we're going to see smaller p-values. What about increasing sample standard deviation for each group?
Larger p-value.
A larger p-value. So now we have more variability within our statistics, so we would have a larger p-value. All right, so these are a review of some concepts that we learned earlier in the semester, but apply to any type of test that we're looking at. So just a kind of a reminder of what we've looked at in the past. So what we're going to continue on with today is looking at the theoretical test of significance for two means. When our response variable is quantitative, then we use the t-distribution, that theoretical distribution, to approximate our p-value. To calculate our standardized statistic is like any calculation of the standardized statistic. We take the value of the statistic minus the null value and divide by the standard error of the estimate. So what that looks like when our data is quantitative is we're looking at the difference in means, x bar 1 minus x bar 2. sample mean for group 1 minus the sample mean for group 2 minus a null value of 0. We're always assuming there is no difference in the true means. And our standard error in the denominator is the square root of the sample standard deviation for group 1. So S1 is the sample standard deviation for group 1 squared divided by the sample size for group 1, N1, plus the sample standard deviation for group 2 divided by the sample size for group 2. And then we take the square root of that entire sum. This, I just want to point out, the standard error of x bar 1 minus x bar 2, it reads standard error of x bar 1 minus x bar 2. This value is equal to that statement. So this does not mean the standard error times the difference in means. It's not multiplication, okay? We're just saying we're looking at the standard error for this difference in means. There is an error in their textbook, especially if you have the hard copy. I'm not sure, I think they might have updated it in the online versions, but the standard error equation is incorrect on page 357 in the hard copy, so make sure that you fix that to match what we're looking at here. We need to square those sample standard deviations. Because we're using a theoretical test here, we have to check our validity conditions. So our variable must have a symmetric distribution in each group, or each sample size must be greater than 20, and the sample distribution must not be strongly skewed. So when we think about validity conditions, this is the same as what we had for a single mean test, but we need to double check for both groups that our sample size is over 20 and the sample distribution is not strongly skewed, or that we have a symmetric distribution. Any questions on this calculations? We're also going to estimate the difference in true means. We're going to look at a confidence interval. So we're going to take our statistic plus or minus the margin of error, where the margin of error is the multiplier, which will be given to you, times the standard error for the difference in means. Now the nice thing is when we have quantitative response variables, that standard error equation is the same for the standardized statistic and for the confidence interval. So we're still just looking at squaring the sample standard deviation for group 1 divided by that sample size, plus squaring the sample standard deviation for group 2 divided by that sample size, and taking the square root. Questions on calculation of the confidence interval? All right, so we're just going to do questions 12 and 13 in the textbook. I am going to ask that on question 12 that you use the formula. So don't do what the book is trying to get you to just use the applet to find the confidence interval, or sorry, to find the standardized statistic, but I want you to use the formula to calculate that standardized statistic. So we're going to take the difference in means minus 0 and divide it by the calculation for the standard error. Any questions on what I want you to do? All right, so I'm going to put you back in your breakout rooms. Coyote, can you hang out in the main room for a second?
Okay.
I just can't make you a co-host when you're in another. All right, so when you calculated your standard error, you should have been squaring the sample standard deviation, so 1.78 for the men, divided by the sample size of 654, plus 1.76 squared for the women, divided by the sample size of 813. So you should have gotten a standard error of about 0.093. Is everybody pretty much finding that value?
Yes.
Okay. Then we're looking at our difference in means, so x bar 1 minus x bar 2. our null value is 0, and then dividing by the value 0.093 in the denominator, so we get a negative 2.473. So remember, this tells us that the sample difference in mean number of friends for men and women is 2.473 standard errors below the null value of 0. So based on that standardized statistic, do you expect the p-value to be large or small?
Small.
Probably fairly small. Remember that we know that 95% of values are within plus or minus 2 approximately standard errors, and this is beyond that 2 standard errors. So we would expect, since this is going to be out in the tail of our distribution, that this would be a fairly small p-value. All right, so 14 through 16 are looking at using the applet. And we were having a lot of issues with the applet in my last class, so I was going to have you work through this or show you how to do this in a different applet. So if you ran through, you could use this regular multiple means applet, but we were having problems with getting the shuffles to show up. So we're going to actually just use this theory-based inference applet up here at the if you want to follow along, you can click on theory-based inference in the other applets. I'm going to go ahead and copy the data. So we're going to look at a scenario of 2 means. And I'm just going to paste the data in. I could also just write the different sample statistics in here as well. But I'm just going to go ahead and paste this data in. I'm going to do it again here. It's not happy. There we go. So now we have the right sample size, mean, and standard deviation for the 2 groups. I'm clicking on test of significance, changing the alternative hypothesis to be 2-sided. And here I can see a standardized statistics close to what we found of negative 2.45. We're doing a 2-sided test and a p-value of approximately 0.0143. So we should have seen a fairly symmetric null distribution in question 14. If we look back at that distribution here, we can see that nice symmetric distribution. If we change over here to t-statistics and check overlay t-distribution, it's froze. Unfortunately, it seems like this applet just does not want to work today, but we would get that same p-value that we saw there. Now it's going for me. Still not getting that overlaid t-distribution, but you get the idea that we're getting a similar p-value than what we saw with the simulation test. So here, this p-value of 0.0143 is approximately what we saw with our simulation. Any questions on those theory tests?
I have a question on the applet itself.
Yes.
Quite recently, it's been freezing up a lot and like won't refresh and everything. Is that just an internet issue, or is it the web page applet?
So it's actually
itself?
just a product of the large sample sizes. So both of these sample sizes are really large, and then also with the project, all of those data sets that data set's very, very large. So it's mostly just that. One suggestion that they made is to have you guys do 500 shuffles at a time, and hopefully we won't have as many issues. I do know that when we're on Zoom and trying to run the applets that we get double issues, so making sure you're not having a lot of things open on your browser will help as well. Any other questions?
Thank you.
All right, so that took us through question 16. So I'm going to go ahead and put you back into breakout rooms to work on 17 through 19, but I do want to make a change on 19 as well. So 17 is looking at the validity conditions. So you're going to have to look at the shapes of your distributions and think about your sample size. And then you're going to calculate the 95% confidence interval. And I want you to use a multiplier of 1.964. So you might want to write this down just so you have this when you're working on these questions. Again, in part B, I don't want you to use the applet. I want you to do this calculation just so that you get the practice with finding those values. So we're doing 17 through 19 in the breakout rooms. Any other questions before I put you in the breakout rooms? All right, so for our scope of inference, you should see that there is a non-causal association because we did not have random assignment to the gender, but we can talk about generalization back to the population because we did have a random sample of American adults in 2004. So thinking about our scope of inference, it's non-causal, but we can generalize back to the larger population. To calculate your confidence interval, you have that difference in means, so 1.86 minus 2.09 because we were doing men minus women. And we're adding and subtracting the multiplier times the standard error that we calculated previously. So you should have found a confidence interval of negative 0.413 to negative 0.047. You guys see these same results? Anybody get something different for the confidence interval? Okay. So when we go ahead.
I got the same thing.
Okay. So remember when we interpret the confidence interval, we want to include that order of subtraction. So we have the true mean number of close friends for American men is 0.413 to 0.047 friends lower than the true mean number of close friends for American women with 95% confidence. Why is it important to think about the idea of 0 not being contained in this interval?
Because 0 is our null. So
Okay.
if it was in the confidence interval, we couldn't reject the null because it's plausible.
Right. So if 0 is our null value, so we got a small p-value providing strong evidence against the null. So we would expect that this interval would not contain the value of 0. All right, so we are just finishing through question 19 for class on Friday. We are out of time, so we'll pick up and talk about a couple of these concepts in class on Friday. And then we'll work on exploration 7.2.